Live Tuition. Hello everyone and welcome to another beautiful and marvelous session. Are you all ready to start the session? Are you all ready for that? So what will you do if you are ready for the class? Usually what will you do? You will give the beautiful thumbs ups, right? Yes, give me the beautiful thumbs ups, quick. Very good. Good evening, good evening. How are you, ma'am? Yeah, I'm doing great. What about you? How are you all doing? Can you give me a smile if you're doing great nowadays? Yes, I can see that beautiful smiles on your faces. Very good. Doing the chapter. So can you zoom that comment? I'm not able to. Yeah, started with the first chapter, fourth chapter, but here we are doing the first chapter. How can they start the fourth chapter by skipping all these? These are the basic things, right? We have to start from the beginning. Then only you will get an idea what is there in the fourth chapter. It's all a continuous thing. So we must study the first chapter first. Then only we can study the fourth chapter, right? So we'll continue in an order, okay? Fine. So I can see so many camera off there. You know that I won't allow the cameras, right? When you join the class and you know you're responsible to turn on the camera, right? After you join the class. If you have joined the class, it's your responsibility to turn on the camera. I have to see everyone, right? Yes, that's it. So everyone, ready for the session? Definitely yes, ma'am. Please begin the session. Yes, and your kind knowledge, it is a YouTube session, YouTube live going on over there. So you can send your link through your friends so that they might get an idea about the YouTube live over there. So let them study too, okay? So let's help others too. So please share the link with others and let them study too, right? Yes. So here we are with the first chapter, matter in our surroundings. Can anyone tell me which was the topic that we were discussing in the previous session? Do you remember that? Yes. Can you tell me which is the topic that we were discussing in the previous session? Quickly let me know. Yes. So definitely we were talking about the solid state, right? We discussed about solid state. Definitely we discussed about the characteristics of solid. Let me rewind again, okay? Let me give a basic idea about the chapter, okay? About the topic that we were discussed. Before that, do we have any new student in our class? Do we have any new students? You can just raise your hand, okay? You can just raise your hand and let me know if you are a new student.
Yes, so we have two new students.
Two new students
Sharia
and one turned on the
and
camera. Who is that?
Sharia and Tirtha.
Sharia, can you please turn on the camera?
Let's unmute Tirtha first.
Yes.
Yes, Tirtha.
Tirtha, I saw your beautiful smile. Tirtha, how are you?
Fine.
Fine. So where are you from, Tirtha?
I'm from Tirupur.
Alright. So Tirtha, we are at the middle of this chapter. Okay, we already discussed the properties and the characteristics of the particles of matter. Now we are studying the states of matter, the three states of matter, and we already finished the first state. And in this session, we are going to talk about the second and the third state of matter. Okay. And for the new students, I'm going to rewind the characteristics of solid again. Okay, let me talk about this again. And we have one more, right?
Yes, Sharia Shifa.
Sharia. Hello, Sharia. Is this your first class?
Yeah, I joined yesterday.
Joined yesterday, so this is your first chemistry class. Am I right?
Yes.
Yes, very good. Where are you from?
I'm from Telangana.
Telangana, alright, very good. So, you join us, welcome to our class or our family 90 plus. Okay, welcome. So here we go with the characteristics of solid. Can anyone tell me what were the characteristics of solid in the comment box? In the comment box, let me know what were the characteristics of solid. Quickly comment it, everyone. Definitely, they are rigid. They are rigid. They are inflexible. We cannot flex this, right? This pen is a solid. We cannot flex it. They are rigid. That is the first characteristic of solid.
Fixed mass, volume, they are incompressible.
We have the answers. Lot of answers in the comment box. Very good. Keep doing that. Keep interacting with me because this is an interactive session, right? So keep on interacting with me. And for your kind knowledge, if you have any doubt, you can raise your hand and ask me directly, or you can ask the questions in the comment box. Our supporting teacher, Arya ma'am, is here. She will help you with that. Okay? Yes. So here we go. The second point. It's nothing but they have a fixed shape. They will not change the shape, right? They have a fixed shape. As this pen, when I keep this pen and come back together tomorrow, this pen will be having the same shape as it before. So they have a fixed shape. And what else? We have a fixed mass and volume. The solid will be having a fixed mass and volume. It will never change again. It's all fixed. And here we go with another one. They are incompressible. We cannot compress the solid anymore. They are already in a compressed state. So we cannot compress it again. So these are the general characteristics of solid. Okay, this is the general appearance of solid, general characteristics of solid. But we know there are particles inside the solid. Now let's talk about the particles. I'm going a bit faster just because we already discussed all these things in the previous session, right? So that's why I'm going a bit faster because we have to complete two more state of matter.
So we have a hand raise, I think.
Hand raise over there, yes.
Ayman.
Yes, Ayman. Do you have any concern?
Ma'am, yeah. So what is we know that solid can't be compressed. They're already in a compressed state.
Yes.
So what is meant by incompressibility?
Incompressibility means we cannot compress it again. They are incompressible. Okay.
Oh, incompressible. Okay.
Incompressible. We cannot compress it again. That is incompressible. Okay. Yes. Incompressible refers to we cannot compress it again. It's already in a compressed state. So that refers to incompressible. So here we go with the characteristics of particles of solid. Particles of solid. We already discussed that, right? The particles of solid, and we compared it with the Rubik's Cube. Do you remember that? We compared these particles with the Rubik's Cube, right? Yes, definitely. And the particles, so the screen is getting off. Here, the tab. So the particles over here, they are closely packed like this. Yes, fine. It's closely packed like this now. Okay. So the particles are closely packed with each other. And the force of attraction between the particles is very, very strong. We cannot separate these particles. So if we want to separate this, we have to apply the force. Then only we can separate them. So the force of attraction between the particles is very, very strong in the case of solid. And the space between them, can you see the space between the particles? It is very, very minimum or negligible. And the last one, the particles vibrates in a fixed position. They vibrate in a fixed position. They cannot move around like this. They have a fixed position and they only vibrate in that fixed position. That about the characteristics of particles of solid, right? Yes. So here we go. This is the solid. And here we have the particles. They are closely packed. As you can see over here, they are closely packed. They doesn't have any space between them. It's almost negligible. What about the force of attraction? The force of attraction is very high. That is why they came together, right? They are very close together because they have a strong force of attraction. And what else? That's it, right? So intermolecular force of attraction is very strong. Interparticle space is very less. You have to keep that in mind. So that's all about solid. Now I have a few questions for you. Okay, this is all about that we have discussed in the previous session. Now coming to today's session. Okay, let's begin the today's session. So here we go. I have few questions for you. So here comes the first question. Rubber band can change its shape on stretching. Will you classify rubber band as solid? So before I have told like the solids have a fixed shape. We cannot change the shape of a solid. But here we go. The rubber band, when we stretch the rubber band, it will change the shape. So can I classify this rubber band as the solid? That is my first question. Okay, can anyone answer me? Can anyone answer me? Yes, rubber band, when we stretch the rubber band, it will expand, it will change its shape. But we already learned that solid cannot change its shape, right? They have a fixed shape. Then how can we classify rubber band as the solid? Yes, if you know the answer, you can just raise your hand and tell me. Yes, ma'am.
Yes, let's ask Tom Sanju.
Who's that?
Tom Sanju.
Tom. Yes, Tom.
Yes, ma'am.
Can you answer this? Why are we classifying rubber band as solid?
Is it because the intermolecular force of attraction is little?
The intermolecular force of attraction is little, but we already studied that the solid have a fixed shape. They will not change its shape, right? But on stretching the rubber band, it is changing its shape. My question is why? Then why the rubber band is considered as a solid? It is changing its shape. So can we consider the rubber band as solid? Tom?
Actually, there's
Yes.
a request to show previously.
I don't know.
Don't know. Here we go with the previous slide. So can we remove this? Oh. So quickly take it down. So do anyone have any idea about that? We have the hand raised over there. Yes.
Yes, let's ask Neha.
Neha, how's your hand, Neha?
It's good, I can write.
You can write. Very good, very good.
Yeah.
Now can you answer my question?
Because the rubber band, when you apply excessive force, it can stretch. But if you don't apply force, it can regain its shape.
Definitely, yes. That's the correct reason. So, have you took down this? Who asked for the previous slide?
Bless
That
me.
was me, ma'am.
Okay, fine, fine. So I'm moving forward. Okay, if you haven't done with this, you can take a screenshot of it. You can take a screenshot of it. Okay, fine, fine. I'm moving forward. Yes.
Tisha, actually, there's a doubt is the clay a solid?
Clay is a solid, but it is mixed with the water. So it have both the water and solids. It's a mixture of that. Okay. Yes. So the animation. So the rubber band, if we stretch the rubber band, it will expand and it will change its shape. As the boy doing over here, where's the boy? The boy is stretching the rubber band over here, as you can see, and when he applied a large force, it just broke. Okay, now what do you understood by this? If we stretch the rubber band, it will expand. If we remove the force, it will regain its structure. It is not changing its structure, it is regaining its structure. And the rubber band, if we kept it alone, it cannot change its shape, right? We have to apply the force in order to change the shape. So if we release it, it will regain the shape. And if we apply more force to it, it will just break. Even though it breaks, it will be having same properties and same size and shape as it is. Okay, so the rubber band is not changing its shape, but it is just stretching. Okay, it is just stretching while we expand it. And if we remove the force, it will just regain its structure. It will just regain its structure. Okay, it will regain its structure. And it can break if we apply the force. It may break if we apply more force to it. But in the normal condition, it is very, very difficult to change the shape of the solid. That is what I meant. Okay, so if we remove the force, it will regain its shape. That is why rubber band is considered as the solid. Okay, rubber band can consider as the solid. Am I clear? Is that clear for everyone? thumbs ups, so that I can move to the next question. I have few more questions.
They are actually in previous class you talk about like spring and sponges.
Yes, I'm going
Okay.
towards that. I'm going towards that. I have told you, right? Our students are so impatient. They cannot wait for anything. So here we go. You can remove it, sir. So here we go with the next question. I have few more questions, okay? Solids are generally non-compressible. Then why can sponge be readily compressed? So spring is the same as the rubber band, okay? If you stretch the spring, it will stretch and it will change its shape. If you remove the force, it will come back to the normal state or the normal shape. So they can be considered solid. Now talking about sponge, okay? Sponge, I have told you, solids cannot be compressed. I have told you they are incompressible. Solids cannot be compressed. Then how can we compress the sponge? So we can classify, can we classify the sponge as the solid? That's my really question. So can anyone answer to me? Can anyone answer me?
Yes, more we have Muhammad Aris.
Yes. Why can we classify sponge as a solid even though we can compress it? The solid
ma'am.
cannot be compressed.
Ma'am, can you hear me?
Yes, I can.
Ma'am, I'm not sure whether my answer is correct, but still I will say.
Yes. What was that? What was the answer?
Ma'am, I'm not sure whether my answer is correct.
No matter whether it's wrong or right, I just want the answer.
Ma'am,
Okay?
when there is solids, if particles are closely packed with like sponge, it's also called a solid, but their particles are not closely packed.
No, it's not like that. The solid will be having closely packed particles, but they have pores in between them. So the animation.
Actually, we have a lot of answers.
We have a lot of answers in the comment box, and they are all correct, right?
With full explanation.
With a full explanation like an essay. Yes, so very good. Keep doing that. So here we have an animation. One kid over there compressing the sponge. And why it is compressing? Supposing. So why it is compressing over there? Because the sponge will be having minute particles inside that, as you can see. You can see them, right? The sponge will be having minute pores in it. So the air will be get trapped inside these pores. So inside these pores, can I write it? No, I cannot. So the air particles or air will get trapped inside the spores. Okay, air will be there inside the spores of the sponge. So what happens if we compress it? What happens if we compress it or squeeze it? The air inside the pores will come out, and that's why we can compress this sponge. Again, so the sponge can be considered as the solid. So why it is compressing? Because it will be having minute pores in it, and inside that pores air will be trapped. So if we compress it, the air will squeeze out from the sponge. That's why we can compress the sponge. So again, the sponge can be classified as the solid. Was the explanation clear for you? Was the concept clear for you? Do anyone have any doubt regarding this? If you have any doubts, you can just raise your hand and let me ask. Okay, let you ask. Okay, you can ask any question that you want. Yes, we have the hand raised over there.
Yes, Niranjan.
Yes, Niranjan.
Yes, so this might be a dumb question, ma'am, but
No worries.
Imagine we are in a place with no air or like basically nothing except a dark room and no air. And would the sponge would be able to squeeze the sponge?
Without any air at the vacuum, I haven't tried that. So when I get the vacuum condition, definitely I will try that with a sponge. Okay, ma'am, do you have any idea about that?
No, I also don't have.
If there is no air, how can the air get trapped inside that sponge?
Yes.
Yeah, that's a genius question. Yeah, that was not a dumb question. That was actually a clever one. So,
But we don't know the answer.
but I don't know how to answer that. So
We don't know that practical condition.
we don't know the condition. We'll go for the opinion
Yes.
for the scientists, and I will research that thing and I will let you know the answer. Okay? Yes, fine. So, any other doubts? Anyone? Any other doubts regarding the sponge?
No. everyone
Can you
is-
please unmute one man?
Okay, let's ask.
No one have any doubts, so I'll ask questions.
Insha. Yes, Insha.
Insha,
Yes, ma'am.
why sponge considered as solid, even though we can compress it?
Ma'am, when the sponge is compressed, the air inside it squeezes out. That's why it's called a sponge. And that's why it's a solid.
Definitely, yes. Though they will be having small pores inside it, so air is getting trapped inside that. So that's why we are compressing it. That's it. And I have one more question. Over here. How sugar is considered as solid as it takes the shape of the container. So I have told you the solid particles will be having a fixed shape. But sugar, when we pour the sugar particles inside the glass, that sugar particle will take up the space of the container or the shape of that container which we are pouring into. So why is that? Then how can we call the solid as the sugar as the solid? How can we call them? So sugar must be a liquid, right? It is taking up the space of the container. It is not the property of solid. Then how can the sugar considered as solid? That's the third question that I have. Any idea about that?
Yes, we have a hand raise. No, not one. There are
Few hand raises. Very good.
Let's ask with Abid.
Abid.
Sabit.
Sabit. Yes, Sabit.
Abid.
Abid. Yes, Abid. Do you have any idea?
We are considered sugar as a solid because when you zoom in, you can see the crystal sugar. It is solid.
Definitely. Yes, sir, the animation. So the sugar particles or the sugar exists as a small particles, sugar crystals. They exist as small sugar crystals, right? So what happens if we pour the sugar inside the cylinder over here? It takes up the space of that container. First they say, that's fine. So the thing is, the sugar particle or the sugar is consisting of single minute crystals, and that minute crystals will be having a fixed shape. Okay, they have the fixed shape, so we can classify them as the solid. They have a fixed shape, but the sugar is consisting of millions of particles, millions of sugar crystals, and they are very small in nature, right? That is why they are taking up the space of the container, even though they have a fixed shape. They have a fixed shape. Looking into each crystals, they have a fixed shape. Even though we pour into another container, the shape of those crystals will remain same. It will never change. It remains the same. That is why sugar classified as the solid. Okay. Is this question, the answer is clear for you? Is the answer clear for everyone? Everyone is sitting like watching movies, but you have to take down everything, right? You have to take down the explanations that I'm going to give, that I am giving. So you have to take down everything. Are you doing that? Thumbs up if you're doing or writing down everything. Yes, my girl children, they're writing it down everything. Very good. So here we go. Understood this, right? So we have completed all the things about solid. Now we have to pass into the next level or the next state of matter, which is nothing but the liquid. We all are familiar with the liquids, right? Can you give me some example for the liquids? Can you give me some example for the liquids? What are the examples that you can give for liquids? So when you think about liquid, what are the things that is coming in your mind? You can tell me that in the comment box. Oil, milk, water, lemonade, and what else? Water, mercury, definitely. Oil, juice. So very good. We have a lot of examples for the liquids, right? We have water, we have oil and honey. And here we go with the juice and milk. Everything is an example for liquid. So you can give a lot of which is that I'm using? Oh, okay, fine. So here we go. We can give a lot of examples for the liquid state. Now we have to study the characteristics of liquid. Characteristics of liquid. Are you all ready for it? You know the characteristics of solid, right? Now exactly we have to study the characteristics of liquid. Here we go. The characteristics of a liquid. Characteristics of liquid. So what will be the first point? What will be the first point? Definitely, they doesn't have any definite shape. They doesn't possess any definite shape. They doesn't have any definite shape. So if we pour a liquid into a container or the glass, it will take up the space or the shape of that container which we are pouring in. So the liquid will not be having a fixed shape or definite shape. They takes up the shape of the container which we are pouring in. So the first point will be they will not possess any definite shape. Okay, they doesn't have any fixed shape. That is the first characteristic of liquid. First characteristic of liquid, they doesn't possess a definite or fixed shape. Fixed shape. So the animation. Let's check it out. So here we have some containers over here, some glass tubes, and let's pour some liquid inside this, okay? Let's pour some liquid inside this and pour this. So here we go. This will be having the shape of that container. They occupy the space of that or the shape of that container which we pour in. So they doesn't have any fixed shape. They takes up the shape of the container. They takes up the shape of the container. Okay, that's the first point. Don't ever get confused or forget this point. Okay, they doesn't possess any definite or fixed shape. Okay, you have to study that right now. They doesn't possess any fixed shape. And you don't have to by heart that. Okay, don't by heart or memorize it. You just have to learn by the concepts. Okay, so imagine one liquid or imagine the water that you have and you can easily write the first point. They doesn't possess any fixed shape. Okay, you don't have to by heart anything. Don't ever by heart anything. Okay, yes, understand the concepts and you can learn it by like that, right? Yes, you can remove it, sir. So here we go. The next point, the next characteristic. But they possess a fixed volume. The volume cannot be changed. They have a fixed volume. For example, I have 100 ml of water in my glass. Imagine I have 100 ml water inside this glass and I am pouring this 100 ml of water into a plate, but the volume will be the same. 100 ml and 100 ml, it will be same. Okay, there is no change in the volume. They have a fixed volume. So if I am taking 100 ml in this beaker, I will get the same 100 ml in this plate too. So the volume cannot be changed. They have a fixed volume, but the shape is changing. They doesn't have a fixed shape. Inside the beaker, they had a different shape, and inside this plate, they will be having a different shape. They occupy the shape of that container which I am pouring in. But the thing is, they will be having same volume or fixed volume. Volume cannot be changed for liquids. Even though they can change the shape, the volume cannot be changed. Okay? The volume cannot be changed. Are you all following me? Thumbs up. Give me a thumbs up. We have the hand raised over there. Yes, ma'am.
Abhineet Pradeep.
Who's that?
Abhineet Pradeep.
Abhineet. Yes, Abhineet. Do you have any doubt?
Like for different types of objects, there is different volume. For example, if it's a rectangular container, it has certain volume. And there is a cylindrical container, it also has different volume. So when
That
you
is the,
pour liquid inside it, doesn't that like acquire the same volume to the object?
no, it's not like that. That's the volume of that container. We are talking about the volume of the liquid. For example, I have a glass cylinder like this, and they will be having a certain volume. The cylinder will be having a certain volume, and I have a cubicle like this, and they will be having a certain volume. The volume of the containers will be different, and the amount of liquid that I'm taking, or the volume of the liquid that I'm taking. For example, I have 100 ml of water, 100 ml water. If I put 100 ml water inside this, okay, I have 100 ml of water inside that, okay, 100 ml water. And from that beaker or the test tube, from that test tube, I poured that liquid, that much liquid inside this. Okay, from that beaker or the test tube, I poured that much amount of water. Completely, I transferred that liquid inside this, and the volume will not change. So, can you increase the amount of water while we pour into this? It cannot happen.
No.
So, even though it takes the shape of that container, the volume cannot be changed. It will be again 100 ml itself. Okay, 100 ml cannot be changed. The volume of the water is never changing while we transferring it. Okay, they are just taking up the shapes of that containers. The volume is never changing. Okay, even though volume of the containers are different, the amount or the volume of the water that we are taking is not changing. They have a fixed volume. Okay, was that clear? Yes, definitely. So they have a fixed volume, but no fixed shape. No fixed shape or no definite shape. Okay, going towards the next point. Liquids flow. We know that characteristic, right? The liquids can flow. The liquids can flow around. That is why they are not rigid. Not rigid. They are not rigid. Liquids can flow. We know that property, right? Liquids always flow. If we pour water on the floor, it will just flow like that, right? The river, the liquids are flowing. They are not rigid. Rigid means they are inflexible. So here, the liquids are not rigid. They can flow. So we can call these liquids as fluids. We can call the liquids as fluids. Fluids. What is the fluids? They have the property to flow. If something has a property to flow, we can call that substance as the fluids. Fluids. So what is fluids? They have the property to flow. They have the property to flow. So that's why we can call them as the fluid. Fluid. Clear? They have the property to flow. So they are not rigid. I can call them as the fluid. Okay. Yes. Any concerns? Any doubts? You can just raise your hand and let me know. Ma'am, can air be a fluid? So I'm coming to that. I'm coming to that. Okay, we are talking about the liquids. So air is coming and the gases, right? We'll discuss that.
I think everyone is.
Here we have honey is considered as liquid and
yes,
honeycomb
we
considered as
already-
Oh, you answered it. Alright, fine. So here we go with the next point. Shall I move towards the next one?
Yes, let's
Definitely yes.
move fast because everyone is
Waiting,
for
eagerly waiting for the
air.
next one. Eagerly waiting for the air. So they are almost incompressible. Okay, we cannot compress them again. The liquids, as like solids, they incompressible. They are almost incompressible. We cannot compress the liquid anymore. So if we take the water inside the anything glass, and we cannot compress that again. Even if we apply the pressure, we cannot compress it. They are almost incompressible as the solids. Okay, they are all incompressible. And here we go. Solids, liquids and gases can diffuse into liquids. That's the important point. That is one of the important point. Okay. Now everyone listen to me. Listen to me. Okay. Solids, liquids and gases can diffuse into liquids. Okay. What is diffusing? Diffusing means they can mix together with the liquid. They can mix with the liquid, okay? Solid, liquid and gas, they can mix with the water or the liquid, okay? Let's take up the solids first. Okay? How can solid diffuse into liquid? Okay? Imagine I have a glass of water. Imagine, everyone listen to me over here. Okay? I'm explaining it. So, I have a glass of water and I am pouring some sugar into that liquid, okay? We know that the water that is inside the glass will be an example for the liquid, and the sugar that I am pouring over there is an example for the solid, okay? Sugar will be the solid and water will be an example for the liquid, okay? Let's take it out how the solid is diffusing into liquid. So if we take a glass of water and let's put 1 teaspoon of sugar into that, the sugar particles will diffuse into water. They will dissolve in water. That means the sugar can diffuse into water. The solid particles can diffuse into liquid. That's the first point, okay? Solids can diffuse into liquid. The sugar particle or the salt particles, they can diffuse into water or the liquid, okay? The solid can diffuse into water or the liquids, okay? That's the first point. Is that clear? What is diffusion? They can mix with each other. That's called as the diffusion. Okay, was that clear? Was that clear, the diffusion about the solid and the liquid? Yes, the solid can diffuse into liquid. Now let's take it out about the liquids. Can liquids diffuse into liquids? Definitely yes. So think I have 1 glass of water, and Dettol. Okay, I have Dettol over here. Yes, ma'am.
Teacher, I think Mariam has some, I don't know, like,
Mariam,
you just call
is
it.
she not well? Mariam, am I audible to you? No, I guess.
I think.
Mariam? No,
Yeah.
she's not responding over there. Alright. Let's come back to the topic. So I have water and Dettol. Okay, I have water and Dettol. So we all do these things, right? So when we mix Dettol into water, they diffuses inside that water. The Dettol particles will diffuses into the water. That means both of them are the example for the liquids. So the liquids can diffuse into another liquid. They can dissolve well, they can mix together well. So solids can diffuse into liquid and the liquids can also diffuse into liquids. Is that clear? That was the second point. Here we go with the third one. We have one more, right? The gases. How these gases are diffusing into liquids.
There is a request to explain why diffusion.
Why the diffusion is taking place. Here we go. Let's take up the water and sugar again. Can you please unmute her? Who's that?
Ritika.
Ritika, can you please unmute her? So here we have the water and the sugar. As we know, if we put sugar inside the water, they diffuse as well, right? They dissolve well. They mix together well. That is called as the diffusion. They can diffuse with each other. Diffusion means they can mix with each other. They can diffuse with each other. So we have water and the sugar. The sugar particles can diffuse into water.
Yes, Ritika.
Yes, Ritika, was that clear? The solid can diffuse into liquid. Ritika,
Yes, ma'am.
is that clear?
Yeah.
And now what about the liquid and liquid? Can liquid diffuse into another liquid?
They can.
They can. So they can dissolve into anything. Okay. So the liquid can diffuse into liquid and the solid can diffuse into liquid. Diffuse means they can mix together. Okay.
Okay, our Mariam, I think our Mariam.
Mariam is here. Mariam,
Yes, ma'am. Yeah.
are you taking down everything?
Yes, ma'am. I have my notebook here.
What was that?
I have my notebook here.
You have a notebook here. The notebook is not enough. You had to write on it, right?
Yes, yes.
Yes, Mariam. Are you all right? Do you have any concern?
Any health issues?
No.
No. Can you just sit down properly?
Yes, ma'am. I think you can't see my camera on.
All right.
Okay, sure.
All right. So what about the gases? Gases, sir. The gases into liquids. Gases into liquids. Here we go with the applications. Okay. How does this gases dissolve in liquid? Again, we have a famous example. Where is it? Here we go. The aquatic animals, how are they surviving? The plants, the animals inside this, or the fishes, how are they surviving inside this water? What do you think? How are they surviving inside this? They are breathing oxygen, right? The fishes and the other aquatic animals are breathing the oxygen in. And what about the plants? What are they breathing in? Is that oxygen or nitrogen? What is this plant breathe?
Yes. I
Yeah.
think everyone has a
What
oxygen.
will the plant breathe for the photosynthesis? Is that oxygen or nitrogen? I have given two options, right? Oxygen and the nitrogen. You can choose from it. Everyone is following the oxygen and nitrogen. Very good.
But there is an answer, carbon dioxide. Sheikh Abdul Mukhi.
Sheikh. Very good,
So
Sheikh.
that carbon dioxide is
So,
answer.
except Sheikh, everyone is like, it is nitrogen, man. The plants are breathing nitrogen in, man. We are damn sure about that. Ashik is also right. No, students, how can the plants breathe the nitrogen in? They breathe carbon dioxide, right?
Not breather, you mean for photosynthesis?
Yeah,
right?
photosynthesis. For photosynthesis, they takes up the carbon dioxide. Yes, the animals over here, the aquatic animals take in the oxygen and the plants will take up the carbon dioxide, not the nitrogen. Okay.
Actually, teacher, you are trying to say that for photosynthesis,
Yeah,
they
for
are
photosynthesis.
Yes.
For the respiration, they are taking carbon dioxide in. No, man. You can just fetch it. Yeah. So, what happens over there? The oxygen. They are diffusing into the water. So the air, or the carbon dioxide or the oxygen that is present in the air is diffuses into the water. They diffuses into the water. They diffuses into the water. That is why the fishes and the aquatic animals are getting oxygen to respire. Okay, that's a beautiful example for the diffusion of gas into liquid. The diffusion of gas into liquid, the air around us, or the oxygen and the carbon dioxide in the air, they get diffuses into the water. So the oxygen will be present inside the water. The diffuses or the dissolves in the water. That's why the aquatic animals are getting oxygen. They are getting oxygen, and the plants, they take up carbon dioxide. Okay, because the gases are dissolved or diffuses into the water. Was that clear? Was that clear? Thumbs up.
We have two hand raises.
Two hand raises. Yes.
From Insha Muhammad.
Insha. Yes, Insha.
Ma'am, you said that solids are being diffused to liquids. So
Yes.
not all sorts of solids can be diffused, right? Like ice and some particular types can only be diffused, right?
Yeah, a certain thing. Some solids are there, they cannot diffuse into the water or the liquids. For example, soil. Soil cannot diffuse into them because soil is insoluble, right? The soil is insoluble, so they cannot diffuse into that. So I'm talking about the general cases, okay? Generally, the soil can diffuse into liquids.
Okay, ma'am.
Yes, and we have
Neha.
one more. Yes, Neha.
Ma'am, you were talking about nitrogen, right? I couldn't understand that part.
Just I confused you, students. I have given two options, oxygen and nitrogen. I was just checking which one will you choose. So everyone go after the nitrogen. The nitrogen is completely wrong. Okay, don't confuse with that. I've just confused you, students. Okay, don't get the nitrogen.
And also we have one more hand raised, Muhammad.
Yes, Mohammed. Mohammed? No.
Ma'am, you said that that the important here is oxygen, right?
Ah.
It's not actually the most important. The most important is water.
The most important is water.
Yes, if there's no water, then how it's done?
So without oxygen, how they will survive? So they need all the things, right? Together. They need all the things together. I said this is an important point, okay? I was telling like this is an important point, okay? Not like oxygen is the only thing that is important. I was not like that. Okay, the point is so important.
Gases. So gases can't like oxygen.
I have told like there is an important application where gases dissolve in water. This is an important application, right? Yeah, the water is also important and the gas is always important too.
No, but water is more important.
Water is more important. And what is his name?
Mohammed, I think.
Mohammed, is that Mas?
No.
Yeah.
Can you please hand this?
You can just hand raise Mohammed. Can you please hand raise?
Yes, Maz, yes.
I knew it will be you, Mas, because you want to start the debate, right? I know, Mas.
Yes.
But I'm not into it. I have to cover the portion, so I'm moving forward. Yeah. All right, Mas. Yes, here we go with the next application. The carbonated drinks. We all like the carbonated drinks, right? We all like the carbonated drinks. So, the carbon dioxide will be compressed inside the water. That is how we get the carbonated drinks, right? The carbon dioxide diffuses into the water and by applying pressure, the gas molecule can be diffused into the liquid, and that is how the carbonated drinks are formed. Again, a well example where the gases can diffuse into water. That is why when we open the cap of this bottle, we are getting the bubbles, right? Just because the gases are coming out. That means the gas can diffuse into water. The gas can diffuse into water. Here again an example for that, or the application for that. Okay. Was the diffusion of solid, liquid and gas clear for you? Was the diffusion clear for you?
I think so.
Yes, very good.
Can you just show that previous slide?
Previous slide,
Means,
the aquatic animals?
No. One. Yes, this
Here.
one. Yes.
Yes, you can take it down. These are the characteristics of a liquid. Characteristics of liquid. No definite shape, but they have a fixed volume. The liquids can flow. That's why we can call them as the fluids. Okay, they can call as the fluids. They are incompressible and they have the property to diffuse. Yes, Neha.
Ma'am, this doubt is not related to the topic, but I'm really curious to know why. So, like when you shake a Sprite or a Coke bottle and you open it directly, it's like it comes out, right? The content, it comes out. Why is that?
Because we are compressing the gas by using high pressure, and we are keeping a lid over there, right? We are putting this gas by inserting a high pressure. By using a high pressure, we are diffusing the gases inside that liquid. Okay, we are compressing the gas inside that liquid by using high pressure. Okay, high pressure. What happens if we just open the lid? The pressure will be decreased. The pressure will be decreased. So the gas which was soluble inside that liquid will just pop out. Will just come out like. Will just pop out like that, okay? So at low pressure, the solubility of a gas in liquid will be less, okay? At first, by using high pressure, we just compressed the gases inside the liquid. So the gases was soluble in liquid. Now we just open the lid or shaken it and open the lid. Again the pressure is decreased. The pressure is decreased over there. So the solubility also decreases and the gas that was soluble inside the liquid will just come out. Okay, like the bubbles, they will just come out. So at high pressure,
Okay,
yes.
Sorry, ma'am.
Yes, that's fine.
And when you like open it normally, it's just the gas, but if you shake it, does it mix with the liquid and it comes out?
Yeah, it will come out like that, right? You can see the bubbles coming out, right? When you just open the lid, the bubbles will come out, right? That is nothing but the carbon
Yeah.
dioxide.
Got it.
Yeah.
Okay, we have two more hand raises.
Yes.
Insha.
Insha. Yes, Insha.
Ma'am, you said that liquids have fixed volume, right?
They have a fixed volume, definitely.
So, ma'am, when you put liquid inside a container, will the container have the fixed volume or the liquid?
Liquid will be having a fixed volume. The volume of the container cannot be changed, right? The volume of the container cannot be changed. So I have explained that, right? If you have this tube and this tube, both of them will be having different volume, and that volume will not change. If you put 10 ml of water inside this and again pouring the water from this to this, again the 10 ml will be the same, right? The volume of the liquid cannot be changed and the container too cannot be changed, okay?
Okay, ma'am.
Yes.
Niranjan. Yes, Niranjan.
Yes, Niranjan.
Ma'am, I had two questions, but one Neha asked. And the second thing, ma'am, you said like while shaking it foams up. What if we add Mentos? How does that work?
I didn't get it.
Ma'am, like when we add Mentos in the Coke, and we close the button, it still foams up.
Yeah, that's perfectly the chemical reactions taking place. There are a lot of chemicals, right? When we put something in, the chemical reactions will take place vigorously. So those are the chemical reactions.
Okay.
Yes. And that's it.
Okay, great.
Here we go with the characteristics of particles. Now we have to learn the characteristics of particles of liquid. Okay, particles of liquid. Particles of liquid. So let me draw it first. If you have a container like this, and there's the amount of water in it, and the particles will be like this. Okay, I'll show you the image. Still, in order to explain this, I'm just drawing it. Okay, I'll show you the image. No worries. So here we go. The particles, consider these circles as the particles, okay? These are my particles, don't confuse with that. Someone is like, what kind of particles is that, ma'am? So this is my kind of particles, okay? Alright, we have the particles inside this container, and as you can see, they are less closely packed. Not like in solids. In solids, they are closely packed like this. They were closely packed like this, right? The solids, they were closely packed like this, but in liquids, they are less closely packed. Okay, compared to the solids, they are less closely packed. They are less closely packed. Now, the second one, the force of attraction between the particles is weak. The force of attraction, since they have space between them, the force of attraction between these two particles will be comparatively less. Am I right? Am I right? Yes, right? So they have space between them, that is called the interparticle space. Interparticle space. They will be having a more amount of interparticle space between them, or intermolecular space between them. So the force of attraction, or the intermolecular force of attraction, will be comparatively lesser than the solids. Comparatively weaker or lesser than the solids. Don't ever forget this. Okay? Don't ever forget this. You have to learn it like they have the space between them. If they must have a space, they will also be having a low intermolecular force of attraction or weak intermolecular force of attraction, because they possess the space between them. If they have the space, the force of attraction will be lesser, right? Yes. And the space between the particles of liquid is medium. Okay, the space, interparticle space is also medium. Okay, it's medium as compared to the solid. They are less closely packed. They have a medium space between them, and the force of attraction is also very less. Okay, if they have space and the force of attraction is less, they will be having a more kinetic energy than the solids, right? They have more kinetic energy. The kinetic energy than the solid. You have to mention than solid, okay? Than solid. more kinetic energy than the solid, so that the particles can move around. Not like in solid, they doesn't vibrate, they can move around. They can move around because they have enough kinetic energy to move around. They have enough energy to move. So they have the kinetic energy since they possess space between them, and also the intermolecular force of attraction is weak, so that they possess the kinetic energy so that they can move inside this container. Okay, so that they can move inside this container. Okay, is the 3 points clear for you? Is the 3 characteristics of particles of liquid clear for you? Is that clear? Ma'am, can you please unmute, ma'am?
Yes. Yes. Let's ask Nital.
Nital, can you explain me about the kinetic energy of the particles of liquid?
The kinetic energy of the liquid is more than the solid.
Definitely. So that they can move around. Very good, very good. That's it about the characteristics of particles. Okay, you have to add one more point. They have more kinetic energy than solids. Compared to solids, they will be having more kinetic energy, so that they are free to move. They are free to move. Okay, fine. So let's have an animation again. So the animation. So here we have the particles. Okay, wait for a second. So here we have the particles over there. There's the liquid and the particles. Imagine that. Okay, you cannot see the particles anyway. Imagine those are the particles of that liquid and the interparticle. No, let's unmute one more.
Okay, let's unmute. Anaka.
Anaka, what are the characteristics of particles that you can give from this particular image?
What particles they are not closely packed, as there are a lot of intermolecular space, and the force of attraction between these molecules are really weak, and particles can move around freely since there are more intermolecular space, and the
Kinetic energy.
kinetic energy is more.
Yes, they will be having higher kinetic energy than the solids because they possess some space between them. Intermolecular space is medium over there, and the force of attraction is very less. The force of attraction is very weak, so that they can move around. So the animation. Here we go. No. Yes, sir, the liquid. Yes. Here we go, the liquid. Here we have the glass full of water and the particles. You can see the particles, right? These are the particles, and as you can see, they have got some kinetic energy so that they are moving around. They got the kinetic energy so that they are moving around, and they have space enough. They have enough space to move around. Okay, they have the space between them, and intermolecular force of attraction is weak, and they have more kinetic energy than the solids so that they can move around. Okay. That's about the liquids. That's all about the liquids. Clear? Give me thumbs up so that we can move towards the next state of matter, which is nothing but what? Which is the next state of matter? We discussed solids and liquids, and which is this next state?
Yes.
Everyone was waiting for that, I guess.
Yeah.
Quiz time, ma'am. We have half an hour more. Who was that?
Sanjit.
Sanjit, can you please unmute him?
Okay.
Sanjit.
Yes.
Sanjit,
Yes, no.
you wanna quiz time now?
Not now, after the classes.
After the classes, we'll be having the quiz time. So, can you tell me which are the characteristics of liquid? Not the particles, just the general characteristics of liquid.
Ma'am, they don't have a definite shape. They
Then
don't have a fixed volume. They are not rigid.
they are not rigid. And what can I call the liquids as?
Fluids.
Fluids, definitely the fluids. And what about the diffusion?
Yes, ma'am.
Diffusion, what about the diffusion?
Yes, ma'am. Solid, liquid, and gases can diffuse into liquid.
Definitely. Very good, very good. So everything is clear so far, so that I'm moving
Yes, ma'am.
forward.
They're almost incompressible.
They are almost incompressible. Very good. So going towards the next one, okay? Going towards the next one, which is nothing but gases. Gases. What are the examples for the gases? CNG. CNG is compressed natural gas. That is the cylinder that you are using in your homes, right? The compressed natural gas. And the oxygen cylinder will be having oxygen gas in it. And the balloons will be filled with the gas, right? And the carbon dioxide. Why do we use this carbon dioxide? Why do we use this carbon dioxide? This one. Why are we using them? You can comment it. Why do we use the carbon dioxide? You have studied that in 8th standard, right? That is a fire extinguisher. Definitely, that's a fire extinguisher. So you can add on more examples for the gases, right? You can give more examples for the gases. Now, all the thing that we have to study is what? The characteristics of gases. The characteristics of gases. Are you ready for it? Can everyone stand up just for a second? Everyone, stand up from your positions. Stand up, everyone, quick. Quickly stand up from your position. If you are not well, no worries, okay? No worries if you are not well. So don't take that as an excuse.
I think
Don't take that as an excuse, okay? Everyone must stand up.
Rishikesh,
Rishikesh, stand up. Everyone, quickly stand up from your positions, quick.
One is.
They are all sitting like that?
Rishikesh.
Rishikesh, why are you sitting like that? Just stand up from the position.
I think.
Yes.
We have no problem.
So everyone, quickly stand up. Quick.
Ayman.
Ayman, do you have any concern? Stand up from position. No, just stand up. Everyone, quickly stand up.
No, he will not.
And just turn around. Quickly turn around.
Yes, that way.
Take around. Quickly take around. Only one round. Stop. Someone is like falling over there. One round is enough.
John was just relaxing in his chair.
One round is enough, right? One round is just enough, okay?
Yes, John, it's enough.
Johnson is sitting in that chair and rounding up. Fine. Now everyone can sit down, okay? Sit down. Alright. Now let's cut into portions. Here we go. The characteristics of gas. Everyone is like getting ready with a pen and book to write down everything. Right? Yes, here we go. They also doesn't have any definite shape. Like the liquids, they also doesn't possess any fixed shape. They doesn't have any fixed shape. That doesn't possess the fixed shape. Okay. So if we pour the gas into one container, it will take up the space of that container. They doesn't have any shape. So if they possess any shape, how can we walk through that air, right? We cannot walk through air if they possess some shape. So our head will be hit on that shape. So that's not happening, right? The air around us, they doesn't have any shape. So they doesn't possess a definite shape or a fixed shape. So when you think about gas, just think about the air around you, okay? They doesn't have any fixed shape around here. So can anyone see the shapes of the air? Can anyone see the circles or squares or rectangles or triangles? Yes, Sahir can see that. Sahir, can you see the fixed shapes for the air? The oxygen is in triangle, ma'am. The nitrogen, they will be having a rectangular shape. Was it like that? No. It's not like that, right? Alright, they doesn't have a fixed shape. No, the gas have a tendency to flow. They also have the tendency to flow. They have a tendency to flow. So the substance which has a tendency to flow, what can we call them as? What can we call them as? Quickly tell me, what can we call them
not
as?
Zahir, actually Zuhair.
Zuhair, it was
So
it was
just
Zuhair.
please call it properly.
Yes, okay, fine. So hi, I know that feeling since I have this large name, everyone will call out different names. So I have that feeling.
May I
so
call
I'm
that now?
sorry. So I'm really sorry for that too. I know that feeling.
Actually, we have a hand raised.
Hand raise
Insha.
over there. Yes.
Yes, Insha.
Yes, Insha.
Ma'am, are clouds gases, liquids, or solids?
Gases, they are the condensed form of liquid. Okay, we'll talk about that. We have the topics like that.
Okay,
Okay,
ma'am.
we'll talk about that.
And also John. Yes,
John. Yes, John.
My question is also kind of the same. What about smoke?
Oh, they are the gases combined with the liquid. Okay, we'll talk about that. We have the topics in our class. Okay, wait for it. Impatient students, they cannot wait for anything.
Okay, also Fatima.
Yes, Fatima.
Actually, my textbook provided SCRT, so I didn't have to cover.
CRT?
SCRT, you are following the SCRT text?
Yes, ma'am. Other competition has
Alright. We have another text SCRT. I will talk to my higher authority and I'll let you know, okay? Yes, here we go. Fluids. Fluids, they can be called as fluids. The first one, ma'am?
Okay, Rishesh.
Yes, Rishikesh.
Ma'am, because I am late.
That's
I have clearly mentioned that in the previous session or the previous class that you cannot be late in my class. And how can you just raise your hand and
It's
tell
1
me
hour
like,
late
ma'am?
actually.
He's like proudly like, ma'am, I was late. How can you tell like that, Rishikesh?
It's 1 hour late.
It's 1 hour late. We have only 15 more minutes left, and you're like, ma'am, how is my question? I'm late, ma'am. How do you feel right now, ma'am?
And also Ishan Muhammad.
Yes, Ishan. Ishan.
Yes, ma'am. I'm not late, but I'm not in a breakout room right now. I think I'm in the main session because I accidentally shut down my PC. I just rejoined.
Okay, fine. No issues now, right?
Yes, ma'am. No issues.
Fine.
It is accident.
Alright, fine. So here we go with the characteristics of gas. We have to finish off today, right?
Okay.
Yes. So gas have the tendency to flow so that we can call them as the fluids. So fluids is not only for liquids, they are also for the gases. So whenever someone asks like, can we call gases as the fluids? You dumb one, we cannot call the gases as the fluids. Only liquids can flow. You have to tell like, as a science student or the chemistry student, you have to argue them that the gas have the property to flow, so I will call them as a fluid, okay? Yes, with that full confidence, you have to tell like, the gases are fluids and they doesn't have any fixed volume. They doesn't possess any fixed volume. They will take up the volume of the container which they are in. Okay, they will take up the volume of the container, they will take up the shape of that container, they will take up everything from that container, okay? So if we enclose the gas inside a container or the cylinder, the volume of that gas is same as the volume of that container or the cylinder, and the shape of that gases will be as same of that container too. So if we have a container like this, okay, and we have a container like this, they will be having different volumes and different shapes. If we fill and we have to close the lid, okay? Otherwise the gas will escape from them. So you have to close the lid, okay? Never forget to close the lid because they will escape. They have a tendency to escape. So always.
Teacher, we have a doubt. If a ball is rolling down a hill, isn't the ball or solid called a fluid?
No, because the solid will be having a definite shape, right? It is not like flowing, it is rolling down. It is not flowing. They are rolling down. How can we call that as a fluid? Never. Okay, who asked that question?
Yes, it's from Insha.
Insha, no. Okay, the solid cannot flow. They are rolling down. They are not flowing. So here they will be possessing different volumes, and if we fill in the gas over here, and we are pouring the gas inside this from this tube again, this container again. So the volume of the gas changes from here to here. It will take up the volume of this container and this container too. So the volume, they doesn't have a fixed volume. They take up the volume of the container which they are filled in. Okay, they take up the shape and they take up the volume of the containers. Is that clear? Not like the liquids. The liquids have a definite volume. They will not change the volume. But in gases, they take up the volume of the containers or the cylinders. Was that clear? Is that clear for everyone? Yes. So the volume can be changed from one container to another container as the gases can take up the shape and the volume of the container. Okay, don't ever make a mistake. Okay. Yes, here we go, the next one. They are highly compressible. They are highly compressible. We can highly compress them. We can compress them. That is exactly what is happening in our CNG. Compressed natural gas. Okay, it is a compressed natural gas, CNG. So we are compressing by using high pressure. So even if we have this much amount of, they are like this. Okay. For example, I have the particles. These are the particles of gases. Imagine these are the particles of gases. Okay. We have a cylinder over here. And these are the particles of gases. These are the particles of gases. And the thing is, we can compress it. We can compress it. Now, what do you think if we compress this? By using pressure, if we exert a pressure on the lid, what do you think will happen? Yes, ma'am. Unmute one.
Okay,
what do you think will happen if we just compress it or apply pressure over here? Since the particle will be having larger space in between them.
Shreya.
Yes, Shreya. Shreya?
Yes, unmute.
Shreya, unmute.
She's hearing actually. Shreya.
Shreya.
Will you please unmute? Yes.
Shreya, I have a question for you.
Actually, she is hearing.
She's hearing and not responding. She's not responding.
Not responding.
So, I have told you, right? You have to respond to my questions. You have to
we
respond to my calls, or I will get angry. Okay?
Let's ask Joel.
Joel.
Yes, Joel.
Joel?
Yes, ma'am.
What do you think will happen if I apply pressure on the lid?
Ma'am, because it is gas, there's a lot of space between each molecule. So when we are compressing, the molecules will come closer together and will be tightly packed.
Definitely yes. So if we apply pressure over here, we had an animation over there, but it's not playing right now. That is why I'm picturizing it. Okay, we had an animation. I'm really sorry for that. I couldn't show that. Okay, I'm really sorry for that. Just imagine, okay? Now just imagine. If I apply pressure over here, if I just apply pressure over here, the particles will be having space in between them. So the space will be compressed and the particles will come closer so that we can compress. Can you put that animation in my PPT slide? In my slide? So if we compress it, the particles can come closer. The particles can come closer. I have a blank slide over there. Right after this. Right after this. Okay. What was I talking about? Yeah, they have the space between them. So if I apply the pressure, the particles can come closer. The particles can come closer like this. Yes. Wait for a second, okay? Yes, over there. So they will come closer, so that we can compress them. So a large amount of gas can be compressed in a small cylinder. That is what exactly happening in the compressed natural gas. Okay, compressed natural gas. A large amount of gas is just compressed inside a small cylinder. And here we have the animation. Yes, finally I can show that. So what happens if you apply the pressure? They can come closer. So the large amount of gas is compressed in the small state, right? They were the large amount and we compressed it. We got this gas in a lesser volume. So that's why I have told you a large amount of gas can be compressed in a small cylinder by applying the pressure. By applying the pressure, we can just compress it. That means the solid will be having high compressibility because they have a lot of space between them. So that we can compress it. They are highly compressible. Don't ever get confused with that. Okay, they are highly compressible. Yes, we have the hand rises over there.
Yes, Christo.
Yes, Christo.
And what will happen if you remove the lid?
I have told you, right? They have a high tendency to get escaped. They'll escape from there. If you open the lid, they'll just come out like that, right? They'll just come out. So we always, if you want to keep one gas inside the cylinder, we have to always close it. Otherwise, the gas can leak. You have heard about the leakage of gas, right? If we have a hole in the cylinder, the gas will leak and we can detect that by your smell, right? We can detect that by smelling. So even though if it is have a small hole over there, the gas will just come out. Because they are highly dangerous, right? The cylinders are highly dangerous because we applied that much pressure to compress the gas. We have applied that much. It is in high pressure. So if we just blast out that high pressure, it will just blast out like that, okay? So even though they have the hole, they will just come out like that because they are in high pressure. They will just come out. Then.
And also Abid.
Yes, Abid.
Ma'am, when you compress solid, like when you compress gas, like the molecular space will become less, right?
Less, yes, definitely. They will get.
Will the gas turn into liquid?
Definitely. Even if we apply more pressure, it will just turn into liquids. We will study that, okay? The conversion of states of matter, there we will study the application of pressure, the conversion of one state to another, how can we convert them, we'll study that.
Okay.
Then,
I think it's
that's it? Alright, they are highly compressible, and they diffuses fastly with the other gases, that's the important point. The diffusion, they can mix with the particles, okay? They diffuses fastly. Right, now let's take an animation. So the animation. I don't have the page for that. Okay, let's check an animation. So the gases can diffuse. It is highly diffusible. Okay, the gases can diffuse with each other, with other gases. That's why we can detect the smell. Yes, sir. That's why we can detect the smell. The cooking. Mother is cooking over there and the gas is coming out and the particles of that gas will mix with the particles of the air and they diffuse with each other and that is why we are getting the smell. Okay, that's how exactly we are getting the smell, because the particles of the aroma of that food will get diffused with the particles of the air around us. That's why we can detect the smell. They are highly diffusible. So the particles of aroma are diffusing into the particles of air. Okay, this is a common example, and we have a incense stick again. Incense stick again show the same property. If we lit on the incense stick, we can detect the smell, right? The particles of that incense stick will get diffused with the particles of air. That's why we are getting smell. And the leakage of gas, as I mentioned earlier, if a gas is leaking from the CNG or compressed natural gas, we can detect it by smelling, right? Why? Because the gas is highly diffusible. They fastly diffuses into the air particles. Why are they fastly diffusing? Why are they fastly diffusing? Because, yes sir, you can remove it. Why are they fastly diffusing? Because what? They have high kinetic energy. They have high kinetic energy. So if the gas particles have high kinetic energy, they will move faster. They have high kinetic energy. If someone have high energy, they will be so fast, right? Likewise, the particles of the gases will possess high kinetic energy so that they move faster. So they diffuses faster into other gases. They move faster so that they have the high kinetic energy. Yes, Ayman. Yes, Ayman.
Ma'am, like what will happen if they move faster in kinetic energy? And one more doubt I have.
They move faster. They move faster. That is why they are diffusing fastly, right? Even though we cannot see them, they are moving so fast over here because they have a large space. They have a large intermolecular space, and the force of attraction is very, very, very weak. So they can move around so freely. They have total freedom in their hand. So they can move around wherever they want. Okay. And they have high kinetic energy. They can move around wherever they want.
And also Sharia has a
No,
And ma'am,
he have one more doubt.
So like when we are in a plane, right? And like when we are in a certain amount of height, like very high, we start to notice water droplets, right?
Yes.
So is that because of the pressure outside?
Definitely, it is because of the pressure, and that is called as the condensation, where the gases will convert into liquid. Okay, we'll study that again in the states of matter, in the conversion of states of matter. Everything is coming.
Okay. Sharia has a doubt.
Yes, Sharia.
Now my doubt is clear.
It's clear. All right. Very good, very good. So let's discuss this again, okay? Let's discuss this and I have a few questions for you. So here we go. They are least closely packed. We saw that, right? The particles, they have least closely packed. If one is here, the another one will be here. And one will be here and here and here. They are least closely packed. They are least closely packed. If they are least closely packed, they will be having enough space in between them. They will be having a large space in between them. I can call that space as intermolecular space. So the intermolecular space is larger. The space between the particles of matter is maximum. The space between these two particles is maximum. They have maximum space between them. If they have maximum space between them, the force of attraction will be very, very weak, right? They are so far away. So how can the force of attraction be very strong? No, the force of attraction is very, very weak in nature. The force of attraction between the particles will be very, very less because they have a large space between them. They have a large space between them. So they have a large space and the force of attraction is very, very less. And they have high kinetic energy. So what they will do? They move fastly. They diffuses faster into other gases. They move fastly. They move fastly. Okay. They move fastly. They have a large space between them. They have a stronger force, least force of attraction, and least closely packed. And they have high kinetic energy. Okay, these are the characteristics of particles of gases. Clear? Was that clear? And here we have a hand raise over there, ma'am.
Okay, Mehrab.
Yes, Mehrab.
Ma'am, does the kinetic energy decrease when compressed?
Yes, the kinetic energy will decrease on compression. On compression, the space will be less, right? So the kinetic energy will also decrease on compression.
Ma'am, sometimes it blasts.
It blasts.
For example, when you compress the balloon, it suddenly blasts.
It blasts because we are applying pressure, right? We are applying high pressure so that they will blast. If we balloon, in the case, the external temperature will also break them. So if we just keep on blowing it, we are applying high pressure and the space inside that balloon is just filled. We cannot fill it again. That's why they are blasting with a high pressure. Alright. That's it. Who's that?
I think Mariam.
Mariam. Can you show me a notebook?
Last page.
Mariam, the last page. Can you show me a notebook where you have written it down? Let me check. Ma'am, can you please check it?
No, we can't see that actually.
A bit closer to the camera.
Actually, I think so. She's right.
She's writing.
Okay.
Alright. Keep doing that. Okay. Fine. So here we go with the characteristics of particles of gases. Okay. Clear, right? Was everything clear? Thumbs ups. I want the thumbs ups from everyone. I'll not move forward until I get the thumbs up from everyone.
Yes, I think.
Yes. So everything is clear for you. So the animation.
Can you show the previous slide?
The previous slide here.
Yes.
Quickly take a screenshot. Quickly take a screenshot. Quick, quick. Let me quick. We are out of time.
Before this.
Before this.
Which one? Yes, this one.
Quick, quick. Quickly take a screenshot. Someone is like, ma'am, it's exam time. Why are you keep talking?
Everyone.
Yes.
They are so much.
They're all impatient, I have told you, right? So the particles, they have a large space between them. The interparticle force of attraction is very, very weak. And here we go with the animation. Is it? Here we go, the gas. These are the particles inside the gas, as you can see over here. And they are moving around. They are moving so fastly because they have enough space over there and they have high kinetic energy, as you can see over here. They are nicely moving, right? They can move around so wherever they want. They can move just like that because they have enough space and there is no one to distract them. There are no one to hold on to them. No one is holding them because they have a weak intermolecular force of attraction. No one is holding. So they are moving around so freely and they have high kinetic energy and they have enough space between them. You have to keep this in mind. Was the three states of matter clear? Was the three states of matter clear for everyone? Everything clear so far? No doubts? No doubts, no worries, nothing, right? The thing is, I have a lot of questions and I will ask that in the next session. I prepared that for today's session but I don't have time. So I will discuss that questions in the upcoming class. If you don't answer, definitely I'm going to give you the positions. Ta-da!
Can you go back to the previous slide?
Go back to the previous slide.
No, one more. So, remove that animation.
This one?
Yes, I think so.
The previous slide.
Is it okay, Mas?
Mas? Alright, so since everything is clear, we have the hand raise over there.
That's
So
Mas.
the exam.
No, I think.
No
you
doubts.
wanna take that screenshot.
Yes, no doubts, right? So everything is clear so far. Definitely for the proof, I'll show you that. So here we have these much questions, okay? I have these much questions and I will ask that in the next class. If you don't answer, Definitely and definitely I'm going to give you the impositions. If you don't write the imposition too, I'll increase the impositions, okay? Alright, that's it. Shall we do the exam? Are you prepared for that? It's exam time. Shall we do that? Are you all ready for that? Give me a thumbs up, give me a thumbs up, quickly give me a thumbs up. Done, right? Yes, sir. The animation. So the exam. It's already there. It's activated now. You can just attend the exam over there, okay? You can just attend the exam and it's already activated there. Ma'am, here, can you please unmute him?
Okay. Abhinay. Yes, Abhinay.
Yes, Abhinay.
Ma'am, could you just explain diffusion one more time?
You want the diffusion?
But now you just do
Oh,
the
right.
exam.
I will discuss that in the next session. Okay, diffusion, I will make it clear.
Exam time, get over.
It is just exam time. We have only 10 minutes for that. So just attend the exam, okay? Just attend the exam. I'll explain that in the next session. Okay, we have only 10 minutes. We are lacking the time. So you must attend it, right? So first attend it. No worries. I will explain that in the next session. Okay, no worries at all. So here we go with the first question. Which form of matter has a definite shape and takes up space, has definite volume, okay? Solid, liquid, gas and clay.
I think not everyone attended the exam. Is it okay?
Are you all attending the exam? Yes, right? Yes, they are doing it, I guess.
Okay. Yes, I think yes.
Yes, the second question. Which form of matter does not take the shape of its container? Solid, liquid, gas or air? And here we go, the next question. Which one of the following has loosely packed molecules? Which one of the following has loosely packed molecules? Carbon dioxide, water, alcohol and graphite. Loosely packed molecules, okay? You have to remember the states of matter. And here we go with the next one. Define a liquid. You have to define a liquid. Choose the correct answer, okay? And here we go, the last question. Liquids and gases take the shape of their containers. Which of the following will take the shape of its container? We have the examples and which one will take its shape of the container. Okay, everyone attended the exam? What was your score? Let me know the score.
Okay, I think.
Let me know the score that you
They
scored.
all are going with 8 out of 10.
8 out of 10?
6, 8.
No one got 10 out of 10. That was a very easy question, right? Everything was so easy. Then how could you get 8 or 6? No, it's better score although. Give me a thumbs up if everyone is done with that, okay? If you're done with the exam, you can just raise your hand or just give me the thumbs up so that we can discuss the questions and I will leave you guys. Yes. Quickly respond to me. Give me a thumbs up, quick. Everyone done with the exam? Yes, they are giving me the thumbs up so that I can move towards the discussion session, right? Shall I discuss the questions? Or someone is like, after discussion, I will do the exam so that I can score the full mark. Is someone waiting for that? Is anyone waiting for that?
No, some of them don't get in that exam.
Don't get in the exam, just go back from the tab. There you will be having a blue button over there. Just press it and you can attend it, right?
They are saying
I got the marks, but I don't know which is my mistake. That's why we are discussing it, right?
Okay, let's discuss it.
Yes, the first question. Which form of matter has a definite shape and takes up space and has a definite volume? Again, which form of matter has a definite shape and definite volume? Solid, liquid, gas and clay. Which is their answer? The question, this form of matter has a definite shape. Has not a definite shape, right? Which was the answer you clicked? Which was the answer you clicked?
Liquid, some of them solid. Both
Some
of the
of them-
answers are right now.
Both the answers are right?
Yes. That's how you get.
Yes, here there's a no, okay. I'm really sorry for that. It doesn't have a definite shape, but it will be having a fixed volume, and it is a liquid. And the right answer is liquid, okay? And the right answer will be liquid. They will not have a definite shape, but definite volume should be there. So that was liquid, okay?
Not fair, ma'am.
Not fair. That was not fair, ma'am. How can we how can you confuse them with that?
Yes,
So I'm really sorry for that. So that's liquid, okay? No definite shape, and they have a definite volume too. So which form of matter does not take the shape of its container? Is that a solid, liquid, gas, or air? There is no confusion in it. Quickly give me the answer. Doesn't take up the shape of its container. Very good, very good. It is solid. It is solid. Very good. It is solid. Doesn't take up the shape of the container, right? The liquid and gases takes up the shape of the container, where the solid will not. So here we go. Which one of the following has loosely packed molecules? Loosely packed, very loosely packed. Is that a gas, a liquid, or solid? Yes, carbon dioxide, definitely it's a gas. Carbon dioxide will be having loosely packed molecules. Very good.
Is the hand raises our doubts?
Why are you raising your hands? Is that doubt or to answer it? To answer it, I guess.
Yeah. Doubt? No.
So define a liquid. Define a liquid. They will be having a definite volume and indefinite shape. So option D is the correct one. Very, very good. They have a definite volume but indefinite shape. Indefinite shape. Here we go with the next one and the last one. So liquid and gases takes up the shape of the container, and which one of the following will take the shape of its container? Is the crayon, or milk, or an ice cube, or the pencil? It's the milk, definitely. It's a liquid, right? So milk is the right answer. Milk is the right answer. I hope everything was clear, right? Everything was so clear, right? Any doubts, anyone? And no doubts. So you have to study everything that we have learned in the session. Okay, you have to learn this right after the class. You have to learn everything. Okay, I will ask the questions. Definitely, I will give a position. Don't ever forget it. Okay. Alright. So I'm winding up the sessions, and thank you so much, for listening to me. And I'll meet you in the next class. Until then, take care and bye-bye. Good night.